Hi, my name is Mr. Vargas. I am one of the Seminole County Virtual School anatomy teachers, and I'm going to be kind of going over some very basic Mendelian genetics about blood typing. Now, you're going to see on my screen what I'm going to be writing. So there are multiple types of blood types, and it's very simple to understand. We've got A blood type, we've got B, we've got C, I'm not C, we have O, and then we have AB. Now, typically with genetics, we only have a dominant trait and a recessive trait. Now, in this case, we have two dominant traits here. What we call that is codominant, but it's going to work very similar to how any other Punnett square is going to work. So our two dominant traits are going to be A and B. Now, it's important to know that A and B can work together, and that's how we get AB blood type. So what I'm going to do, I'm going to go ahead and write out what the alleles are going to look like with A, B, and O and AB. So remember, the alleles are essentially the genetic coding that we can have for our blood. Now, remember, this identical set is going to be called homozygous. And then we can have homozygous with B. And then we can have heterozygous with both. Now, remember, I'm going to represent the recessive trait in blue. So we can kind of see both sets going on here. Essentially, what would happen here is that this coding right here would make A, so would this. This one would make B, and this one would make B as well. Now, if we were to have two of the recessives together, we end up with O. Now, we only have one option for that, and that's going to be the homozygous recessive. Now, if we were to pair up the dominant of A and B together, we would actually end up with AB. Now, when, say, someone who has an AB blood type has a child with someone who has an O blood type, we can set it up on a very simple Punnett square. Please forgive how horribly disastrous this looks, but that's okay. So let's kind of put this together. We got our alleles, and now segregation does require that they are independent from each other. So let's kind of keep that in mind. We got then O set up. Now, if we were to pull all the A's down into their respective boxes for this Punnett square, and we do the same with the B's, let's make that look a little bit nicer. There we go. And then we do a cross with our recessive traits. You would see that if we look at our little handy dandy chart, that this right here would be A, and this would be here A. Now, this right here would be B, and this would be B. So the chances of them having a child with, let's say, A blood type, 50%. The chances of them having a child with a B blood type, 50%. Let's do O, 0%. There is no chance of them having a child with O blood. And then also with AB, which is a possibility, they also don't have any chances there. Only way that you can get AB blood type is if someone who is homozygous has to have both options there. Now, if this person was heterozygous A, then we could potentially have an AB set up here. Or if this person was a homozygous A, then there's the potential there. But the idea there is that AB blood type and O blood type will never produce AB or O blood. I hope this helps. If you need anything more, just let me know.